Okay, we're back again. So this time we're almost done with our stock solution. I didn't want to waste your time waiting for me to fill the flask. I did fill it, but not quite to the mark. I don't know if you want to zoom in here so everyone can see the graduation mark on the neck of the flask is right here, but my water is right here. I have a little bit of water still in my beaker, so I'm going to add a little bit more. As you know, bottom of the meniscus must be on the line there. And now I probably should get a pipette. I won't go over. So I'm going to use my Pasteur pipette. I probably could use a wash bottle also. I feel more comfortable with the pipette. So if you look closely now, hopefully you can see that the bottom of the meniscus is right at the mark. So I now have prepared exactly 1 liter of my stock solution from potassium nitrate. Piece of parafilm here, I'm going to stretch it over the mouth of the flask, cover it, wrap the edges of the parafilm around the flask tightly to create a tight seal, and then I'm going to invert the flask to mix the contents, and I'm going to do so at least 5 times, usually 10 times is recommended, doing so slowly and making sure none of the solution is escaping, of course, because I sealed it tightly. Probably did it more than 5 times. So now my stock solution is ready and prepared. So at this point, what you would have done if you had to make your own solution, clearly this flask is way too big to fit in your drawer, so you would put it in a flask of your own, and you would be working with a partner or partners, so you would split it in between several partners' flasks and seal it and save it in your drawer. And then you would use the stock solution to prepare standard. So let's talk about standard solutions. This experiment requires 4 standards to be made. These 4 standard solutions must contain these 4 concentrations of nitrogen, varying from 1 milligram of nitrogen per liter to 2 milligrams of nitrogen per liter to 5, and then finally 10. So 4 solutions with varying concentration of nitrogen expressed as milligrams of nitrogen per liter or 1 ppm must be prepared. For this purpose, we're using another volumetric flask. This time, as you can see, it's much smaller than the one we just used. This is actually a 250 milliliter volumetric flask. Just like this one, it has the same shape, also has a graduation mark. You've used these before. So the question now becomes, how can we use this stock to prepare the standard in this flask? Well, we actually can use what's called a dilution formula, which we talked about in the beginning of the semester. Dilution formula M1V1 equals M2V2, where M1 and V1 are molarity and volume of the starting solution before it's diluted. So in our case, this would be our stock. And then M2 and V2 will be the concentration and volume of the resulting standard solution. I want to point something out that's very important and sometimes confuses students. Here, technically, capital M stands for molarity, molar concentration, which is expressed in moles per liter. But we are not talking about moles per liter. I recently mentioned that we're actually talking about milligrams of substance per liter rather than moles. However, I'd like to point out that milligrams of nitrogen would be proportional to its moles, and so dilution formula still applies. We just don't use moles per liter for concentration. Instead, we use milligrams per liter. But dilution formula is still applicable. So let's consider how we would use this dilution formula to prepare, say, our first standard. So first standard would be 1 milligram of nitrogen per liter solution. So how would we use our dilution formula? Well, we would have to use dilution formula to express V1. We would have to find how many milliliters of stock we would be using to prepare our standard solution. V2 is 250 because we are making 250 milliliters of standard in this volumetric flask. M1 is molarity of stock, and of course, as we discussed previously, that concentration of stock would be 250 milligrams of nitrogen per liter. I keep saying molarity, it's not actually molarity, it's the concentration expressed as milligrams per liter. And the desired concentration after dilution, or final concentration, would be 1 milligram per liter. So V1 would then be expressed as M2 times V2 divided by M1. And so M2 here is 1, V2 is 250, and M1 happens to be 250 as well. So not much math is required here to see that V1 would be 1 milliliter of stock. So the task is to take out 1 milliliter stock solution, transfer it into the smaller, the 250 milliliter volumetric flask, and then bring the volume up to 250 milliliters so that meniscus is right at the mark. So how do we measure 1 milliliter solution as accurately as possible? Well, what we're going to use is called a serological pipette. It's a pipette that's graduated from 0 on the top to 10 here on the bottom. So the maximum amount one can measure with this particular pipette would be 10 milliliters. As usual with these pipettes, we use a special bulb that allows us to draw liquid in or out. And I'm going to show you how we prepare our first solution here. I want to point out that using the pipette usually requires the pipette to be rinsed with solution that we're using, which is our stock. So we're going to do that, and then we're going to make our first standard. So to use the bulb, we would locate 3 valves. One is A, stands for aspirate, S here in the middle for suction, and then E here on the side for empty. So I'm going to press on A, and I'm going to depress the bulb. And if the bulb is used properly, when I let go, it should stay depressed like this. So now I'm ready to draw the liquid in. I'm going to place the tip of the pipette well into the liquid, and I'm going to press S. And hopefully you can see that when I'm pressing S, liquid goes in. Now I got my liquid in. Now I'm going to empty it back into the flask. This is just sort of to coat the inner surface of the pipette with the liquid that's going to be measured with the solution that we're going to be measuring with it. And as you can see, to empty it, I'm pressing the valve on the side, which is E. So now I can once again fill the pipette, and I'm going to fill it to slightly above 0. As you can see, 0 is right here, and my meniscus is above it. So now I'm going to adjust the volume by pressing E. To where the bottom of the meniscus is exactly at 0. So now I'm going to put the tip of the pipette over the mouth of the 250 milliliter flask. Now I only need 1 milliliter, so look, I'm starting at 0 and I only want 1 milliliter, so I only want to go down to here. So I only need this much to be delivered. So I'm going to carefully monitor my meniscus as I'm dispensing. And I stop right here where 1 is. So I delivered exactly 1 milliliter of my stock solution into my 250 milliliter flask. Now I can add enough water to have the bottom of the meniscus sit right at the graduation mark here, and I'll have prepared my standard. So if you were to continue with this, you would take another flask like this, and you would measure 2 milliliters of the standard of the stock, and then add enough water to the mark. You would have created your second standard, and then you would use 5 milliliters of stock, and you would prepare the standard with 5 ppm nitrogen, and then eventually 10 milliliters of stock to prepare 10 ppm standard. I'd like to point something out here, so let me fill the pipette back to 0 again and set this aside for now. So I would start at 0, and if I needed 2 milliliters, I would go down to 2 right here. And if I needed 5 milliliters, I would go down from 0 to 5 right here. And if I needed 10, I would start at 0 once again, but this time I would go right to 10. And I would stop where my meniscus was touching the mark here. And this would allow me to measure very accurately exact volume of 10 milliliters for my 10 ppm standard. This is all for now.